Here's my first video on maths. In this video, with which I invented the Church of Maths, I am going to show you a very neat trick that can be used to do some easy practical calculations. This is a multiversal law, one of my favourites, which I call dimensional conservation, or conservation of dimensions. It applies to all shapes in any dimension. The difficulty level of this video I'll give about 3. It's the first video I've ever given a difficulty level, so I'll need to invent later on how difficult each level is. I decided it should be level 3 because you'll need to know the basics about times tables and dimensions, but that's about it. It is extremely easy to understand, this one, and will be very helpful to know in practical situations. I will give a practical example that came up for me today. I was looking at the communal bathroom, the toilet paper supply, and a few days ago I gave one of my toilet rolls that I'd used 50% of the thickness. So I wanted to know exactly how much I had given away out of the full toilet roll. I know that I'd used the outer half, which is bigger than the inner half. So I was wondering how much is left. I assumed the original thickness of the paper was the same as the diameter of the card cylinder in the middle, and I'll show that the answer is 3/8 of the original amount, or 37.5%. Here is a picture showing the problem. So if you use a toilet roll so there's half of the thickness left, how much did you really use? The red area is clearly more than half of the full roll, with the middle area, middle circle being what's given away. This is a very neat trick to use, as I've said. We'll highlight the middle area in green first. As some example dimensions, let's say the thickness was 4 centimeters, and that is also equal to the diameter of the inner cylinder. So let's say that the inner cylinder is 4 centimeters as well. Different toilet rolls, of course, have different dimensions, so not all toilet rolls will be like this, but if you can imagine, it would pretty much look like this. I actually measured a new one recently and it turned out to be 12 centimeters across, which would be pretty much these dimensions. So we can convert this into a 1D shape, which describes all of the relevant dimensions. Instead of saying 4 centimeters now, we just say that a third of the line is the center and there's a third on either side. That's the outer diameter of the original shape. And this same set of measurements can be used to describe a square. So it's the same portion of the square, it's the same portion of the circle, even though it's a different shape, because the dimensions are conserved. The full circle is changed into a square, and the circle in the middle is also changed into a square, so you know that the portion of the circle in the center is the same as the square in the center, compared to the big square. If we divide this up into thirds on each way, first of all, you can see quite clearly that each square is 1/3 squared, which is 1/9. We know that the central part of the square is 1/9. quite clearly from that. The used parts, which are highlighted in red, are half of some squares, or 3/4 of the ones in the corners. We know that it's divided into halfway along the outer thickness, so we can divide each square into 4 small squares and then count the squares. This is just to prove dimensional conservation. Under this new setup, it is now 6 times 6, so you need to know your times tables for this bit. There's 36 squares altogether, and if you count up the green ones for the centre, you can see it's 4 out of 36, which is 1/9, as we know. If you count the red ones, which are used, you get 20 out of 36, which is 5/9. If you count up the ones that were given away, we have 12 out of 36, which is 1/3 available. The same applies to the circle, which has the same one-dimensional description. We have 1/9 of the centre, we have 3/9 available and 5/9 used. If we take away the central area, we have 8 parts for the final answer, leaving us 5/8 were used and 3/8 were available. Why don't you need to use pi when calculating how much of the circle was used? Because it's an area that's proportional to the square of a one-dimensional length. You know that the white and green together are 2/3 squared, which gives you 4/9, and you take away the third from the middle and you get 3/9. So the white area is 1/3 of the total area, and what's remaining is the 5/9. If you take away the green, then you've taken away 1/9, leaving you 8 parts, which are the red and white ones. The white one is 3 parts, and the red one is 5 parts. So it's 3/8 of the white and 5/8 of the red. I hope you've enjoyed this video, and I hope I will be making many more videos of all kinds of difficulty levels, from basic number lines to complex and advanced engineering, mathematics and beyond. Maths is an infinite and mysterious subject that describes nature in all her wonder and glory.